It's kind of weird to think about, but what if a set of data had a personality? I mean, just like a person, right? Some data is balanced, some leans one way or the other, and some is just prone to extreme behavior. So that's what we're going to do. We're going to learn to decode that personality by looking at two really key traits, skewness and kurtosis.
But first, let me ask you this. Why can a simple average be so, well, completely misleading? You see averages everywhere, right? The average salary, average test scores, we're surrounded by them. But have you ever stopped to think that maybe that single number is hiding the real story?
Well, the secret is all in the shape of the data. Yep, every single data set has its own unique shape, and that shape tells a story. So today, we're moving beyond just one boring number, and we're going to get to know the data's true character.
All right, first up, skewness. This is all about the data's tilt, or its lean. It's the first personality trait we're going to check out, and it basically tells us if our data is nice and balanced or if something is pulling it off to one side.
So what is skewness, really? Well, at its heart, it's just a measure of asymmetry. Think of it like one of those old-school balancing scales. Is it perfectly level, or is something heavy on one side making it tilt? That tilt, that imbalance, that's skewness.
Okay, so to understand the tilt, we first need to know what no tilt looks like. And that's our baseline, a perfectly symmetrical distribution. You've all seen this, right? It's the classic bell curve. This guy has zero skew. Everything is just perfect. The mean, that's the average, the median, the exact middle number, and the mode, the one that shows up the most often, they're all holding hands right there in the center. Perfectly balanced.
But let's be real, the world is almost never that perfect. So let's use a classic example you'll definitely get: income. Imagine a company. Most of the employees are making a pretty decent, middle-of-the-road salary. But then, you've got the CEO and a couple top execs, and they're making millions. Those crazy high salaries, those are our outliers.
Now, watch what those big earners do. They act like a magnet for the average. They literally grab the mean and yank it over towards them, way over to the right side of the graph. This is what we call a positive skew. See how that tail gets stretched out in the positive direction? That's the pull in action.
And here is the absolute crucial point. You got to remember this. In a positive skew, the mean is always greater than the median. That average income number you hear about, it gets totally inflated by those few super high salaries. The median, on the other hand, gives you a much, much better sense of what a typical person is actually taking home.
Okay, so that's one direction. Now let's flip the whole thing on its head. Picture this. You just took a super easy test. Almost everyone aced it, right? High scores all around. But there are always a couple of people who maybe didn't study at all, and they got really, really low scores. See? We've got outliers again, but this time they're way down at the bottom. And you guessed it. Just like before, those low scores have a powerful pull. They reach out and drag the average, the mean, all the way down to the left, towards them. And this creates a negative skew. The average score for the whole class gets pulled down just because of a couple of bad results. So what's the big rule here? For a negative skew, the mean is now less than the median. Again, the median score tells you the real story, that most people did great, while the average makes it look like the class did worse than it actually did. It's deceptively low.
All right, so we've got the tilt down, but that's only half the personality. Now we're going to talk about something called kurtosis. And if skewness was about the tilt, kurtosis, this is the tail of the tails. And trust me, it's all about expecting the unexpected.
So kurtosis literally measures the tailedness of the data. It's not about how high the peak is in the middle, it's all about what's happening way out at the ends, in the tails. It asks a really important question. How often should we expect crazy extreme outliers? Are they like a once-in-a-lifetime thing, or are they more common than we think?
Okay, check this out. It's the perfect comparison. On the left, you've got your standard normal bell curve. The chance of something extreme happening is pretty low. The tails are thin. But look at the one on the right. That's a distribution with high kurtosis. See how the tails are kind of fatter, heavier? That's not just for looks. That means there's way more data hiding out there in the extremes.
So if there's one thing you remember about kurtosis, make it this. High kurtosis means fat tails. And fat tails mean a much, much higher chance of something truly wild happening. We're talking about things like stock market crashes, 100-year floods, the really big stuff you don't normally expect.
So who cares about fat tails, right? Well, you should.
We all should, because understanding this is absolutely crucial for managing risk. Think about it. If you're building a bridge or investing money and you assume everything is normal, but really your data has fat tails, man, you could be in for a world of hurt. You're basically ignoring the huge flashing warning sign that a disaster is way more likely than you think.
Okay, let's bring this all home. Why does this shape stuff matter so much? Because knowing about skewness and kurtosis isn't just some party trick for stats class. It's about learning to read the full story. It's about not being fooled by the simple headline average and seeing what's really going on underneath.
So here's the super quick cheat sheet. Skewness, that's the tilt, the asymmetry. And what's the one thing to remember? Outliers pull the mean. Got it? Good. Kurtosis, that's all about the tails. The visual? Fat tails means high risk. Simple as that.
At the end of the day, this is your superpower. Understanding the shape of data is what stops you from being misled. It lets you see past the headlines, see the nuance, see the risk. It helps you see the complete, unfiltered picture.
So I'll leave you with this question. Now you know the basics. You know how to spot a tilt, how to look for those fat tails. What's the personality of the data in your world? Seriously, think about it. Your grades, the stats of your favorite sports team, the price of gas. The stories are everywhere, and now you know how to read them.